Hello, this is Matthew Symes, and today, joined by Talon Carter, Josh Palaggio, and Stanley Bailey, we are going to present our capstone project of pulse radar object classification with machine learning. Our project uses C++ code on Arduino IDE to control 4 stepper motors. We have 2 motors for the x-axis and 2 motors for the y-axis. Here you can see our motor code running in the command window of Arduino IDE. To start a scan, all the user must do is enter 1. Each line labeled pulse shows an x-axis step and a radar scan. As well, each line labeled y-axis down shows a step down in the y-axis. Our C++ code also determines the distance between each pulse and communicates with our Raspberry Pi on when to step and when to scan. And here's a short video of our pulse radar system scanning a square. Now, I would like to hand it over to Talon to talk about the next part of our project.
Hi, this is Talon, and I'm going to talk a little bit more about what exactly is happening with the radar. So, being that it's a pulse radar, we send out a series of pulses, and those pulses are measuring distance in millimeters. On occasion, we may get a 0 back with the radar due to some stability issues with the rail system. However, it's not necessarily detrimental, as all those errors will end up getting convolved anyways. But all that data is getting transferred to a data set, or a text file, which will then be sent over to MATLAB to be converted into an image. As you can see here, these are all the measurements that we got. Luckily, we didn't necessarily get any zeros, but yeah, that's that.
Hello, my name is Josh Palaggio. The matrix I is filled with values that, when compiled and run through MATLAB's image processing, will reveal to us an image. After running the program, we decide we'd like to save the figure in MATLAB, which contains approximately 7 different filtered images. These filtered images are quite useful for image processing, with binary, meaning black and white, being the easiest to work with when it comes to edge detection.
Thanks, Josh. Perhaps one of the most difficult aspects of our project was this last step, which is the actual classification process. Of course, we use machine learning to do that. It took some time after much research. Here, what you see is us running the epics, or the training scenarios. This is 1,000 images of shapes, triangles, rectangles, squares, but also our own images of our radar data and with it as well. And so as it trains and goes through the epics, we see that it gets better and better at accuracy ratings. This is important. It helps us to classify our image data coming in. Now, this, of course, is sped up. It actually takes a very long time, relatively, and this is we're running through these epics quite quickly just because we're speeding up the video. But you'll notice that it gets more accurate as it trains more, and it's just great. At the very end of this cycle, we get about a 49% accuracy rating on the shape that we initially detected from the beginning. So this project was quite fun. It was challenging, but we had great success and a great team to implement it. So, but that concludes our project and our process to get from point A to point B.